Good morning, children. Today we have to discuss a new topic. The topic name is having name as motion. Right? Already we have little bit knowledge about motion. So in 7th class or in your previous classes, we have that idea about what is motion. Simply, the motion means any material which changes the place changes the place with respect to the means based on the surrounding objects. For example, me is came in starting of the class from one side to middle of the camera means I change the place. So for that myself is in motion means I change the place. So changing of place by any object or any material that should be we called it is in motion. So in that we have wide variety of concepts, right? In that first thing, it is having a wide scope and great information, right? That is, what is relative? So this is the very important term in the topic of motion, right? So what is relative? For that, here we have to take one concept or an example. So this is you consider as globe, right? Right? So if not, this one you simply consider as earth, right? So for example, this earth I taken on the rough diagram on the book. But actually we are all members are present or taking the shelter or living thing on the earth, right? So if I am present at this side, like this. So we thought that this is the top of the place and this is the down place. Means this is we call as up, this is we call as down. Then here no one is present. No one is present. Just we have presented here. Even though, right, whoever is there at here, that candidate is considered as this is up and this is down, right? Are you got the clarity? If single person is there here, remaining sides, if you are not having any persons, then you are considered this is up, this is down, because that should be general observation. Same thing, here the person is changed to this side, then ultimately he is also considered that this is up and this is down, right? So here the consideration of up and down is changed based on the person or not. So the person is the candidate what we call as observer. What we call observer. So observer can decide which is up and which is down based on his particular observing area. Observing area. So this term is introduced by Einstein. So relative term is firstly introduced by Einstein. So especially relativity is a best example with explanation of up and down. For example, here I am taking one duster, right? So in front of me I have the duster. If I place the chalk piece like this, right? So this is up and this particular one is down, right? For example, if I hanging to the ceiling, right? So here no ground is present. If I place it like this, so this is up, this is down, because I take an reverse action, means I hanged from the ceiling. So whatever the hanged ceiling is there, that I consider like a flat one or regular one. Then this is how can I appear? This is should be appears like right in upward, and this one is downward. Got the clarity? Like that we have the changes. In the same way, we have left and right directions. For example, I am facing towards you. For that, this particular side is simply right one and this particular side is left one, right? Because here myself is observing my two hands, right hand, left hand. Then here, if I change the direction like this, then ultimately this is right and this is left. Then you got the clarity. When I change the face direction, ultimately my hands also able to show the direction change, right? So left and right also can't possible to decide strictly or perfectly. It is depends on whoever the observer is there. So observer, if it is change the place or direction, ultimately he can able to change the direction of right and left. Same thing, one more, day and night. For example, we are already familiar on the earth, one side we have the India, in the opposite side we have USA, what we call as America. So we are familiar. In India, if you have day session, means morning session, then ultimately in USA that is night session. Right? Here, day and night also can't be perfect. If I am living in India, my friend is living in America, right? If I make the call good morning, that we are able to say good night. Because me is in the time of ante-meridian, he is in the time period of post-meridian, right? So this day and night also relative terms, because it is depends on observer. Me is observing daytime, my friend is observing night time, right? Same thing here. If I stay at America, my friend is staying in India, right? Again, I am able to wish him like a good night because I am in night, right? So post meridian side, he is in anti meridian side. Then ultimately, the particular sessions are changed or not. So same thing, day and nights also can't be possible to say in particular manner. It is depends on observer. Same thing here, rest and motion. For example, if you are standing in a bus stop or in bus stand, right? Say any buses are moving from your place, right? You are feeling like, yes, I am in same place, but bus is moving from the point of bus station, right? If you sit in bus, right? If bus is starting to move back or front, when you observe the particular location of bus stop, then you are able to feel bus is at same place, but bus stand or bus stop is moving either forward or backward. So that is depends on whoever the person is observing that condition. So these all conditions, up and down, right and left, day and night, and rest and motion, these all things should be depends on the person or the thing what we call as observer, right? So observer means the person who is inspecting the things, especially directions, right? Either up and down, right and left, or sessions, day session, night session, and rest and motion, right? So these all things initially introduced by the scientist Einstein, right? So he is the person introduced the first time about relativity, right? Have you got a clarity? Here we have to discuss about the distance and displacement. This is the next concept in the topic or in the lesson of motion. So to know about the word about distance, just you have to think about two places, right? This is you consider as it is place something like Hyderabad, right? And this is I consider like Delhi, right? These are the two cities which is present in the India. Just you have to think. Then, if you able to move or if you able to travel from the place of Hyderabad to Delhi on roadway, we have a different road direction like this, right? If I choose to travel in airways, means in the aeroplane, it is directly able to move in straight line, right? It is directly able to move in straight line because aeroplanes cannot be move on road. Then it can able to move directly in straight line due to which is having as navigation, right? So here to move on the road, right? So on moving of road, I am able to move in different curved path, right? So it is not straight path, it is curved path. So whatever the curved path is there between the Hyderabad and Delhi, the point of Hyderabad to the point of Delhi. Or in one more time, simply we consider this is point A, this is point B, right? So to move from this point in a curved path, that we simply call as distance. Distance in simply we call the path in curved one, or the curved path between the 2 points we simply call as distance. Same way, one more is displacement. This is one more term in the topic of motion, right? Here coming to displacement, whatever the straight line path is there, or whatever the shortest distance is there in a straight line direction, that we call the displacement. See, this is the displacement, straight one or shortest distance or shortest path between the 2 points. So this we call as displacement. For that, this one distance we call as, it is not having any direction. Simply we call as no direction is present. But it is having magnitude. Magnitude means simply we call as value. Right? So simply we call as value. So for distance, no direction is there. See, we have different directions. Sometimes in right side, sometimes in upward, sometimes in downward. Right? Directions is changed or not. But displacement is having direction is present as well as magnitude also present. Magnitude. So due to no direction but having of value, magnitude simply we call as value. Whatever the distance is there, that we call as magnitude. Right? Here magnitude also there. Here you consider this is simply 10 kilometers from point A to point B simply. Then this is we consider as 20 kilometers. 20 kilometers we call as magnitude. This is value of distance or not. Then same way 10 kilometers, this is also we call the magnitude of what? Displacement. But here displacement is having single direction. See, it is able to show only from my left side to right side. There is no change in the direction. For that, direction is present, magnitude also present. So whatever the physical quantity, so this is quantity, right? It is having expression with magnitude certain value and having no direction. For that, such type of physical quantities we call as scalar quantity. So distance is a scalar quantity. Scalar quantity. But displacement is vector quantity. Vector means simply it is having a starting point and able to show single direction. So this is we call as tail and this is we call as head. Head indicates the direction of particular physical quantity. Here displacement is the physical quantity and distance also physical quantity. But the distance is not having any direction, no direction is present, but magnitude is present. Here displacement having direction as well as magnitude. Have you got a clarity? Yes, here we have to discuss one more topic, right? The concept is what? Speed. Simply, any object which covering certain distance in an instant of time, that is carrying of speed. Any object which covering of certain distance in an instant of time or in a unit of time, that we call the speed. That is the definition. Or simply the rate of change of distance. The rate of change of distance we call as speed. Right? So that is the definition. So this is the object what I consider, right? Which is moving on a curved path. So it is in 1 second, in first second, right? So it is at this particular one at 0 second, means in starting of time. This is 0 second at this time. It is at here. Then after 5 seconds, if it is reached to here, right? So this is covering certain distance or not? Then ultimately it is having certain time period or not? So how much distance is covered in a particular instant of time, that consideration we simply called as speed. So speed in mathematically we can express like this: speed is equal distance by time. So this is the principle or mathematical expression. Here speed we can able to represent with a symbol. That symbol is v. Speed we can able to represent with the v. And here distance we express it with or represent with s, and time we express it with the t. So simply this entire one we shortly represent v is equal to s by t, right? So it is having units. Units means comparison. Already we have a knowledge, right? So simply it is having MKS units or SI units, meter, kilogram, second system or standards of international system. We have the units as for distance meters, for time seconds. For that speed is having units as meter per second. Moreover, speed is depends on distance or not. Here distance already we discussed. Distance is a physical quantity which having no direction. Same, speed also not having any direction because the object is moving on curved path. So direction is changed. For that, speed is also scalar quantity. Which quantity? Scalar quantity. For that, we have to take one example how to find the speed value. Right? For that, we have to take one example here. So here we have to take one problem. Right? How to calculate the speed. Right? So for that problem is like this. An object covers the distance, means it is traveled a certain distance. The distance value is 10 meters in 5 seconds of time. So we taken 5 seconds of time. Then find the value of speed. So how to find the speed? For that we have principle. Speed is equal distance by time. Right? So first we have to write the data. Here, what is the distance value? Simply the distance value we have here is, this is what? Distance means we simply represent with s. For that we have to write the value 10 meters. How much? 10 meters. And here 5 seconds of time. So time we have to take here. The value is t, that is 5 seconds. Then substitute in the principle. How much distance? 10 meters. Right? How many seconds? 5 seconds. Right? But no need to write these two. Just we have to take only numerical expression. So 10 is the distance one, 5 is seconds. Then 5 ones are, 5 twos are. So simply it have the output as 2. Then you have to write as this. This is meter per second. So that indicates the speed of particular object is 2 meters per second. Means in every 1 second it can able to travel 2 meters distance. So this is the calculation or this is the process to solve the problem. Have you got a clarity? Here we have to discuss one more word as, right? That is velocity. Then what is velocity? Simply, if any object which is moving on a straight line path, that we call the in velocity. Or else an object which covers the covering of distance in an instant of time, that we call the velocity. Or else we have one more definition, that is the rate of change of displacement. The rate of change of displacement of an object we call as velocity. Or simply the object which covers certain displacement in an instant of time, that we call as velocity. So here velocity having the expression is like this. Velocity is equals to, here we have to write as a displacement. What we call displacement. Displacement is in straight one or not? Right? So displacement by time. So velocity is equal to displacement by time. Here velocity also expressed with the symbol is v. displacement also expressed with the same s, and t is as usual like t, right? So time indicates t. So previously we discussed v indicates again speed. There is no separation for the representation of velocity and speed, both are same. And distance and displace also both are able to show with the s. There is no specifications. They are having unique identity, right? In the symbol representation, both are having same common principle. Then here displacement and time ratio for the velocity is, so it is having units as meters per second. So meters indicates displacement, second indicates time. So in what? It is in MKS system. Moreover, the velocity is a vector quantity because displacement is a vector or not. It is having direction, single direction. For that, velocity also having a vector quantity, or velocity also considered as vector quantity. Right? So here we discussed about displacement, distance, speed and velocity. So in that distance and speed is scalar quantities and displacement and velocity is vector quantities. Right? Have you got a clarity? Here we have to discuss one problem to solve the velocity. Right? Here the problem is an object travel 20 meters displacement, right, in 5 seconds time period. Means in 5 seconds of time it covers the 20 meters of displacement. Then find the velocity. For that we have a principle. First we have to write data, right? First we have to write as solution. In that displacement, right, is equal to, displacement value is how much? S is equal to 20 meters, right? Then it having time as 5 seconds. So time is t, that in 5 seconds, right? So the object is like this. It is moving from one point to another point, right? In a straight path. So that is the diagram. Then we have to find the velocity. So velocity is equal to, we have a principle, displacement by time, right? So here displacement value 20 and time value is 5. Then 5 ones are 5 fours are, right? Then we can able to write 4. Then displacement is in meters or not? So meters, and time in seconds. So the answer for this problem is velocity is 4 meters per second. Means in every 1 second of time it covers the displacement as 4 meters. Right? Like that we have to solve. Moreover, in last, after solving of problem, if you not written the units, if you not specify the units, right, you will lose the marks. Right? So we have to keep it in mind. In data we have to specify. After that, in answer also we have to specify. Clear? Here we have to discuss one more concept, that is average speed. Right? Here we have to explain the average speed with some values and with simple representation. So here I taken different points: point A, point B, point C, point D, point E. There are 5 points, right? So one object is moving from point A to point E, right? In that, so in each and every point gap, that here I mentioned with hours. Here 1 hour, here 1 hour, here 1 hour, here 1 hour. Means the time gap between point A to point B. So it taken 1 hour time to travel the object. Then what is the distance? 10 kilometers distance. From point B to point C, in 1 hour time it travel only 5 kilometers distance. Then from point C to point D, in 1 hour time it travel 15 kilometers speed. So in from point D to point E, it travel 10 kilometers of distance. Then in this entire journey of the object, then what is the average speed? So here speed values are changed or not? right? So how to calculate the average value? Same like you have knowledge, if you got different marks, right, in different subjects, we are able to get average marks, means total subjects by, sorry, total marks by total subjects, right? So same way here also we have to take average speed. Average speed is equal to total covering distance. Total covered distance by time taken, time or time is taken. So here how much distance is traveled, total distance we need. For that we have to take the value as first 10 kilometers distance, after that 5 kilometers distance, after that 15 kilometers distance, and 10 kilometers distance. There is a 4 distances in the entire journey from different points between. So A to B 10, B to C 5, C to D 15, and D to E 10. Then how much the time value? 1, 1, 1, 1. In all intervals the time gap is 1 hour. For that 1 plus 1 plus 1 plus 1. Then the value of these all things, 10 plus 5 15, 15 plus 15 30, plus 10 40. So total distance is 40 kilometers. Then how much time? So this is 1, 2, 3, 4. Right? 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. So the total time or time taken to finish the entire journey is 4 hours. Right? 4 ones are 4 tens are. For that, the average speed is 10 kilometers per hour. That indicates in every hour and an average, but not exactly. Right? An average, he covers that, or that object covers 10 kilometers speed per every hour. Like that we have to calculate. Have you got a clarity? Here we have to explain a concept as average velocity. So average velocity means the total covering displacement which in a total time taken to finish the journey. That ratio is equals to velocity. The two average velocity. So here we have to take an object is moving from a point A to point D. In middle of we have B and C as the middle points, right? So here we have the displacement values are like this. The point A to B, the displacement value is 20 meters, B to C is 10 meters, and C to D is 5 meters. And the time interval to travel from A to B is 3 seconds, B to C is 1 second, and C to D is 1 second. Then here we have to calculate average velocity, right? Average velocity like this. Simply the total covered displacement, here 20, here 10, and here 5, and the total time taken, simply the total time is 3 plus 1 plus 1, right? Then here 20 plus 10 is 30 plus 5, 35, right? So 35 meters, that you have to keep in mind, but don't write it here. Then 3 plus 1 plus 1, 3 plus 1 4, 4 plus 1 5, 5 ones are 5 sevens are. Then the output is 7. 7 is what? Already the distance in meters, here time is in seconds. For that we have to write meters per second. So the average velocity of that particular vehicle which moves from point A to point D is 7 meters per second. That indicates in every second and an average it covers the 7 meters of distance. Have you got a clarity? Yes, here we have to explain a concept as uniform speed, right? So uniform speed means in every particular intervals or in same time intervals, if it is the object covers same covering distance, that's said to be in uniform motion or uniform speed, what we have, right? For that, here if you have to take in an object which is able to travel in 5 seconds of time interval, 10 meters of distance, and in second time interval, that too in 5 seconds, if it is travel 10 meters, in third time interval in 5 seconds, if it is travel one more 10 meters of distance, in last instant of 5 seconds of time, again if it is travel same 10 meters of distance, then this particular object is in uniform speed. How? For that, we have to take calculations, right? So first I am taking the cumulative values of time intervals. In first interval, that is in 5 seconds, right? In second interval also 5 seconds, means 5 plus 5 we have to take it as 10. Then after time interval, that is also 5 seconds, means 5 plus 5 plus 5, 15. And in one more, here we have one more session or time interval, that is again 5, means 5 plus 5 plus 5 plus 5, means 15 plus 5, 20. Right? So here we have every value is the difference as 5. Then same way we have to take cumulative values of distance. So if you take the distance values, right, the values first instant of time interval is 10 meters. Then if you take a second instant of time interval, that is 10 meters, means 10 plus 10, 20. Then here one more time, third instant of time, that is again in 10 meters, means 10 plus 10 plus 10 we have to take as 30. Then in last instant of time, the cover distance again in 10 meters, means 10 plus 10 plus 10 plus 10, means 30 plus 10, here 30, here 10, we have to take directly 40. Then from this we have to get the difference is again, the value is 10 is difference. So 10 between 10 and 20, between 10 and 20 and 30, the difference is 10, and 30 and 40, the difference is 10. Then this total one is looking like, okay, we have the data, but it is clear expression is possible with a graphical expression. So for that, we have to take a graphical expression. This you consider as x-axis, right? Whatever the line with horizontally drawn to the surface, that we call x-axis, and vertical one we have to consider as y-axis, right? We have to take that. Then we have to take the scale, that is especially important. So what is scale? Simply scale indicates in every particular certain unit of distance we have on graph paper 1 centimeters value difference, right? Here whatever the long or thick line is there, that indicates 1 centimeter gap between any two thick lines. So here on x-axis, right? So 1 centimeter of value we have to taken as, this is 0 second, 5, 10, 15, 20, right? Then on y-axis again we have to get thick lines. So this is I taken as 10, 20, 30, 40. So same thing we have to write. So in 1 centimeter on x-axis, that indicates 5 seconds, right? On y-axis, right, 1 centimeter indicates 10 meters, right? So that we have to write. So 10 meters. Then from this cumulative one, we have to take the representation. So in 5 seconds of time, how much distance is traveled? 10 meters of distance. So these two are able to coincide like this, right? So this is the meeting point. Same thing, in 10 seconds it is traveled up to 20 meters of time. So where is the 10 seconds? This is the 20 seconds. And this is 20 meters. So these two are able to join it here. See, like and like. Then in 15 seconds of time it traveled 30 meters. So this is 15 seconds, right? And this is 30 meters, right? In 20 seconds of time it traveled 40 meters. So this is 20, right? So then join the all lines from the null point or 0 degree. See. So this line indicates the object is in uniform speed. So this is the graphical expression. Have you got a clarity? Here we have to explain one more concept, that is instantaneous P. For that, first we have to take one example. if you are moving on a rough road, generally what we are having in village route or single routes, or in now the season is monsoon, right? Due to floods or due to water storages on the road, right? We can able to get in somewhere in rough condition, right? So at that time we can't be move with the same speed. Where we have a particular comfortable road, we can able to move in our suitable speed. If you have rough one, means if you have something up and downs, right, we are ultimately able to change the gears. Ultimately the speed of vehicle is getting changed. So in that time, so we can able to use the instantaneous speed. So especially this is clearly identified, especially in the vehicle with the speedometer. Which meter? Speedometer. So in speedometer we have one needle. That needle every second it can able to show particular value. How much speed you are maintaining that particular instant of time. So that we call as instantaneous speed. So the speed of vehicle in a particular instant we call as instantaneous speed. So it is simply identified with the speedometer in digital meters or else in ordinary meters, either in two-wheelers or in whatever it may be, right? So in all things we are easily to identify with the speedometer, right? So the speedometer always indicates about instantaneous speed. Then here, how to know or how to identify that particular instantaneous speed? Simply, if an object is moving with a different speed, so that I can graphical expression like this, then this is I consider a something time t1. So it is having a certain particular value of speed that you taken as s1. So this is the covering distance. The ratio of distance by time, it is speed. Then same way, if you take one more instant of time, that is t2, and it covers certain distance, that is s2, because second time interval the covering distance is something, right? So distance values. So it is on what? Y-axis. This is on what? X-axis, right? Then whatever the value we got in first selected instant of time, that may or may not be matched this particular one. So that we are going to write as this s1 by t1, that is s2 by t2, right? So for any vehicle which is moving on a particular rough roads, so this particular value not equal because the speed is varied, right? For example, if the object is moving with a uniform speed, so here I mentioned non-uniform. If it is non-uniform speed, the object is in non-uniform speed, s1 by t1 value is not equal to s2 by t2, because in different instant of time the value of speed is different. But object is in uniform speed. Which speed? Uniform speed or uniform motion or uniform velocity. The value of s1 by t1, that is equal to s2 by t2, because that should be in uniform speed. Means in every instant of time the speed is same. Have you got a clarity about instantaneous speed?